Hello students, welcome back. And in this lecture, we are going to discuss about the references. So let's see what are the references, how we use them. So whenever you create a new variable, you write something like this: int a is equal to 10. Okay, and then if you have to create a pointer which is pointing to the address of this variable a, then you write like this. Okay, and you know that if you change anything like asterisk p is equal to 11, if you make it 11, then you can understand that it will become in place of a, if you in place of asterisk p, if you print a, then in that case whatever you have modified at this location using this asterisk p, which was pointing to the address of a, that will be reflected in a, because you are directly going to that address and then you are modifying the value. Okay, so if you run this, then you will be able to see that the value has been changed for the a as well. Okay, so this is the pointer variable. Let us see the output first. So it's a bit slow, you need to keep a bit patience. So yes, now it will give you the result, and the result will be 11 because it has changed the value at that particular location. So you can see the output is 11. Okay, so this is about the pointer variables which you are aware of. Okay, and if you have studied about the C language, then in C language you might have studied about the pointers. So pointers are basically pointing to the address of the variable wherever it is storing some values. Like a is storing value 10 at some location. So if we want to know, if we want to store the address of a, which is the memory location, or you can say the memory address, that memory address you can find out using this address of a. So using this ampersand operator, you can find out the address of a, and that can be assigned to a pointer variable. Any change in this variable will be reflecting the changes to the associated variable to which it is pointing to. This was about the pointers. Now, the one more variable type, which is known as the reference variable, we can create, which is declared like this: int r, int reference of r is equal to a. Okay, so when you want to create a reference of a variable a, then or any variable, then you use this reference, you can say the ampersand operator here. Okay, so whenever you create a reference, then what we are creating, what we are doing, whenever we are creating a reference variable, then we are creating just another name of a variable. Okay, so a is r and r is a. In very simple terms, you can understand like this: whenever you are creating a reference variable, you are creating another variable. Okay, you are creating another name of a variable. Okay, so if you print like cout endl a, and if you print like r endl r, then you will be able to see that both the a and r will print the value 10. Okay, so both the values 10 has been printed. Okay, you can see that. So in this case, what we are doing, we are just creating a name, another name for the variable a. This r is referring to the to the value stored at the address of the variable. Okay, so whenever you create a reference variable, then it points to the value. Please keep it in mind that it points to the value stored at the address of the particular variable to which it is referring to. So here r is referring to a. Okay. So if it is referring to a particular value stored at a particular location, then you can easily understand that if we do any change in r, suppose I want to, you know, perform r is equal to 11. Okay, like that. So in this case, not only r but also the value of a will be changed, because a and r both are same. Basically, they are a is the alias of r, or you can say r is the alias of a. Reference variable is just an alias of the original variable. Okay, so if I run this, then you will be able to see a and r will be having the value 11. So both will print 11. Okay, so both the values 11 has been printed. So you can see that. So now you might have understood that this reference variable, what it is doing. This reference variable is just another name for a variable, another variable, and any change to this variable will be reflected into the other variable. Okay. If you do a is equal to 11, then also a and r both will be having value 11. Okay. Okay. Now let us see what operations we can perform and how we can declare the reference variable. So can I declare the reference variable like this? I just want to create a reference variable, but it is not referring to anything initially. Can it be compiled? So let me compile it. Right click on it and then just compile it. And if you compile this, then you will find a compilation error. Okay, you can see our reference must be initialized. Any reference variable that you are going to create, that must need to be initialized at the place it has been declared. Okay, so you must need to do this like this. Int reference r is equal to a. Okay, now let us see another thing. Suppose if I do something like this, I'm creating a reference variable and I'm assigning a constant value, suppose 100. Then will it accept it? What do you think? Is it going to accept it? The answer is no, right? Because reference variables are created to point to the value stored at some address of the variable. This is a constant. This doesn't have any address in the memory. So this is not a valid operation with the reference variables, and hence it will give you the compilation error again. It will say like cannot convert from int to int reference, because it can only convert from int to int reference when the value at the right hand side is having some variable, is a variable, right? Okay, so these are the two things that you have seen. So we can do this thing. This is the right thing to do. And now if I do something like this, r plus plus, can I do this? Can I do this? If I do r plus plus, then r's value will be incremented by 1. So should it increment the value of a as well? The answer is yes, because if you are doing any operation with any of the reference variable, then the same will be reflected to the variable to which it is referring to, and vice versa. Okay, so if I run this, you will be able to see that a and r both will be printed as 11. Okay, so this r plus plus, all the addition, subtraction, all kind of operations, they can be performed on the reference variable. Okay. Okay, now let us see one more beautiful thing about the reference variables. And that thing is like you can say, if you create another variable int you know c, and if you assign this r, can you do this? Int c is equal to r. Can we do this? Let us compile this. Yes, we can very well do this, right? But if I change the value of say C, suppose I make it C++, so I am going to make C as 11. So if I print like uh, C and R, okay, so C has been incremented by 1, which will make it 11, because 10 has come to R and R has been assigned to C. So C is also containing the same value, which is 10. So if I do C++, it will become 11, right? And if I print it here, then it should be printed as 11. But what the R will be printed here? If you see this carefully, C is not a reference variable. Okay, so if we see this, if we run this, then you can easily understand the output. I think you might have predicted the output. So 11 is the value for C, but R has not been changed. Reason being, C is not a reference variable, right? It is not referring to some value stored at the location which is storing the value stored in R, right? So that is why C has been incremented, but R has not been incremented. But if I do something like this, then what will happen? If I run this, both the values are 11. So you can understand that a reference variable can be created for another reference variable as well. Okay, so let me write it. A reference variable to another ref variable can be created. Okay, And if I print A here, what will happen? C is referring to the value R. C is a reference variable for R. So it is again pointing to the same location where A is stored, right? The value is stored at the location where A has been stored. That value is also referred by C. So if we do any change in C, that will be reflected to all the reference and the referee variable. Okay, so A will also become 10. Sorry, 11. So if you see, both A and C have become 11. So I hope you might have understood the concept related to the reference variables, how they are used and how they are created. Okay. Okay. So let's see a few more things related to the reference variables. Okay. Can we, you know, can we create another variable which is referring to a reference? Okay. In what I'm trying to say, you might have seen that in case of C++, if you write like int asterisk p is equal to address of A, and if you want to get the address of p, because p is storing the address of variable A, where the value of A has been stored, that address will be stored in p. But if at some point of time, if you want to know the address of p, which means the address of the pointer itself, then what you do? Int asterisk asterisk q and is equal to address of p. Something like that you do, right? And that is a very valid statement if you know about the pointers. This happens with the pointers. This you can do with the pointers. But the question is, can you do this with your references? So let us see. Let me just remove these two lines and let us see. Can I do something like this is equal to R? Okay, can I do this? Let me compile it. You can see that it's okay. It's C. Let me just remove this. This C is not anymore. So let me just compile it again and let's see what happens. Okay, so initialization cannot convert from int to int double reference. Okay, this double reference, which is the double ampersand operator, you cannot assume this as a reference to reference. Okay, just like pointer to pointer, you use double pointers, but in case of reference to reference, you don't need to do double references. Okay, you can just do like this. If you have to create another variable, just create another variable, say R1 or F1, whatever you want to do, and then make it like reference R1 is equal to, R. So this is now pointing to R, or you can say A. Okay, so many reference variable can point to the same variable. That is also a point. Many reference variables can point to same variable. Okay, so if I compile this, you will be able to see that it has been succeeded. Okay, so if it is like int reference of r is equal to a, then if you have to create a reference to the reference, then you can do something like this. Int reference of r1 is equal to, sorry, it should be r. Int reference of r1 is equal to r. So if we do like this, int reference of r1 is equal to r, then you are creating a reference to reference. Okay, very simple. This is very simple, right? Any change in R1 will be reflected in A as well. Okay. So for the references, we have seen for now this much. So uh, to create this, you can note to create reference to a reference, no need to use double ampersand. Okay. Just create another reference variable. Okay. So that is the thing. If you have to use it, you will need to create another reference variable. So we can make it a bit separate from others. Okay. Now let us see another thing. Suppose I have another variable, int b is equal to 20. Okay. And I have created one reference variable with name r, which is pointing to the value stored at the location where the value of A has been stored. The address of A, value is stored at the address of A. Whatever has been stored, that has been referred by R. Okay, at next line, I want to refer it to B. Can I do this? Can I do this? Is it possible? Okay, so this is possible, but let us see the result. R is pointing to B. Okay, what will be the result? Now, if your R is pointing to B, then what will happen? If I make a change in R plus plus, then if I print B and A both, then in which variable the change will be reflected? Okay, it will be in B. Will B become 21 or will A become 11? That's the question. Okay, so let me run it. Okay, so B will be, 20. Okay, and A will become 21. So if you see this, it's like first I have printed B, which is 20. So B's value was 20. If you created R++, then B value has been incremented. Watch it carefully because I want you to understand this. It should not confuse you. Here I have created a reference variable which is pointing to A. Okay, so at this point of time, at this line, it has started pointing to the variable A. After that, I want it to point to some other variable. R is equal to B. It is pointing to the other variable, but is it referring to the variable B? No, it is not referring to the variable B. Basically, it is not overriding the this statement. Basically, here you have created a reference to A, and here you are trying to create a reference to B, but it is not creating a reference to B. Basically, compiler has not done this reference allocation for you. Okay, so even if the statement is valid as per the compilation, but once you have referred one reference variable to some other variable, then that reference variable cannot refer to any other variable. It will not give any compilation error. Please remember this. Most of the times it has been asked in many of the interview questions, right? So if some variable, reference variable has started referring to some variable, then on the next line or at some point of time, if you want to refer it to some other variable, you cannot do that. Okay, this is a very important concept. So let me write it here. Once a reference variable starts pointing to some variable, then it cannot point to other variables, which means it cannot create a reference. It cannot be used as a reference for any other variable. It will keep referring to the very first variable that you have referred to at the time of initialization. So whatever you have done at the time of initialization, that is important. At the time of initialization, to which variable you are pointing to, that is the important thing. So that's the only thing that you need to remember, and this is very important. In your code, you might do these kind of mistakes because if you do this R is equal to B, this is not a legitimate action. This is not a legitimate work that you should do. But your compiler will not give any error, and that is the main problem. Because if your compiler will not give any error, it will not warn you. Then in that case, what will happen? In that case you can do the mistake, and sometimes it may happen that this kind of mistake has been done by someone and you are not able to find that mistake in code because it is not giving compilation error, and somehow you are not able to understand this. Somehow you don't know this, but if you know this, then you will be able to find the issue that yes, we are doing something which is not legitimate for the references. Okay, so this is basic information about the references, and this is kind of information that is for if you are learning something new in the C++ language, and if you are at the references, then this much information about the references is pretty much sufficient for you. Okay, so here one more difference you can spot between the reference and the pointers. In case of pointers, you can start pointing to some other element. Suppose if I create a pointer here and if it was containing the address of A, and on the next line if you start pointing to some pointing to the address of some other variable, then it will be fine. After overriding, it must have been pointing to address of B. In case we have used the we could have used the pointers, but in case of references this is not true. So this is another difference between the pointer and the references. Okay, so at the same time you are spotting the difference between the pointers and the references. That is really good thing. So I hope you are enjoying this video and you are learning a few more a few important things. So before I conclude, let me show you some usefulness related to the reference variables. Suppose I have created a function void test fun. Okay, and in the test fun, suppose you have some variable in reference of A and in reference of B, and you want to change the values, interchange the values of A and B with each other. Then what you will do, uh, normally when you don't use this, let me just again use A and B here, and let me call the test fun, and let me pass A and B. Okay, so if I do this, A and B are here, and when you are passing the variable A to this A, then it is creating a reference. So basically, when you will be calling this function, basically this A inside this test fun will be referring to the value stored at the address of A. Okay, I hope now you are catching the line. Okay, this line is the important one. A reference variable, sorry, it points to the value stored at the address of the variable. Okay, and it manipulates the same value. So if you do like this in reference of A, and if you're passing like test fun AB, then whatever value A contains, that will be used as a reference to this A variable. So which means if you make any changes to this A, that change will be reflected here as well. Okay. And if you do any changes in B, that will be reflected here in this main function, because you are referring to the same variable. So basically when you are creating a reference variable, then you might now have understood that there is no new memory allocated. Okay, when you create a new a reference variable, I'm just writing ref. So when you are creating just a reference variable, then it doesn't create a new, it doesn't you can say it doesn't allocate a new memory or and a new assignation. So whenever you are using the reference variable, then you are doing the changes at the same location that has been provided to you. So your, at the runtime when your program is running, it doesn't need to create any new memory area. It doesn't need to, allocate a new memory area where a new variable will be created. Because in case you are not using this reference A, then you know that in case of functions, whenever you pass a new value to this A from here to here, then what will happen? This int reference of A is not there. Then it will be like int A is equal to this A. So in that case, this particular A will be a new variable that will be allocated in the memory. Okay, so that is the problem with the normal variables. But if you are able to identify that you don't need this, you can directly allow the change in the variable at the location where it has been stored. Then you can use the references. So just like right now, I'm just going to interchange the values of A and B. A and the values of A and B will be exchanged. So let me do like this: int temp is equal to A, then A is equal to B, then B is equal to temp. Okay, so I have just exchanged the values of A and B. So if I print here cout endl A and cout endl B, then if you print it now, if you run it, it will be compiled perfectly fine. There is no issues. So if you run this, then you can see like the value of A was 10 and B was 20. Now you can see the value of A has become 20 and the value of B has become 10. Okay, because I have interchanged the value here. So if you do the changes in test function, if you are using the reference variable in the arguments, then in that case any changes will be reflected here. So you can see that A has become 20 now. Okay, and B became 10 now. Okay, so this is the importance and significance of the reference variables. Suppose in your test function, you might have heard about the structures if you know about the C language. Okay, so structures, you know that there are number of variables inside the structure. At some point of time, a structure can contain, a pointer which is pointing to some dynamically allocated memory. Okay, and it could be a very huge structure. Okay, and if you pass that structure to some function which is not taking any reference variable, in that case, a whole new memory will be allocated for your new variable, and you need to also take care of like whatever pointer variables are there, same things should have been created for the new variable inside this function. Okay, so wherever your structure variable is pointing to for a particular memory location, that particular memory location you must need to be pointing to with your new variable. So overall, a new variable will be created, which is of the same structure type, and it will take some time. It will use some space in your memory, so that is not that efficient. And if you know that this is the only object which is roaming around, okay, and this is the only object that you need to modify, or you need to perform the actions, then why not to use the references? So using the references, you can pass a big structure variable to a function, and you can make the changes and they will be reflecting in your function from where they have been called. Okay, so here if I do like int a and int b rather than reference, then you can see that a and b will be printed as, you know, they will be simply printed as 10 and 20. There will be no change. Even if we have done the changes in test fun, they will not be reflected. And you know the reason. Okay, 10 and 20 you can see. The reason is that these are the local variables, a and b. These are the local variables in test fun. So once this function calls comes out, once this function call is done, these a and b, which were the different variables which were only active inside this function, they are gone. They have not done any changes to the real location of these a and b variables. Okay, so this is the important use of the um, reference variables, and in case of structure variables, where big structure variables are there also it is very much useful. So I hope you might have understood the concept. You can go to the notes section as well, where I have uploaded the documents. You can take those documents, and these notes will be sufficient for you with respect to the references. And now I guarantee you that whatever type of question you will get for the references, your concept is now very much clear, and you will be able to answer the questions very efficiently, and you will be able to give the answers correctly. Okay, you might have developed a mindset with respect to the reference variables. Okay, so that is my purpose, to tell you the best of the things in this particular course, so that you can gain best of it. Okay, so we'll meet in the next video. Till then, have a nice day, and bye bye.